Hello, Bismillahirrahmanirrahim. We meet again at the discussion about the PWM generator using PIC16F877 or 877A. From the previous video, we have learned the introduction of the PWM generator, pulse width modulation generator, and also answer the sum of the question. The first one is what is the PWM? That as we know that the PWM stands for the pulse width modulation. Can use to many application. What is the application of the PWM? For example, for the robotics application, for the control of the light intensity and also the light intensity of the RGB LED, something like that. And then we need to know about how it works using some of the animation, maybe some of the explanation that we have discussed about that in the previous video. Now we continue about our PWM discussion. So the first one, you have to know about the register, okay? Take a look right here. The register of the PIC16F877 or 877A. There are three registers right here. You can use this to configure or to operate the PWM feature itself. So the X1, the X in this registers is according to the number 1 or number 2. So if you use the PWM, so you can configure the PWM itself in the CCP1 con, and then the others is CCP2 con. And also to hold the 8 MSP of the PWM, you can use because the high part of the PWM registers and the CCP con. So if you use the CCPR1L, so you can CCP1 con and so on. But either you use the PWM1 or PWM2, they are using the timer 2. Okay, this is free running counter, which will be compared with CCPR1L or CCPR2L and the PR2 for generating the PWM outputs. So I think that you only have one frequency, but you can change or you can configure the duty cycle for each of the PWM channels. So you can have two PWM channels using the difference of the duty cycle, but with only one frequency, because the one frequency is good in the TML2 compared to the PR2. Okay, just I mentioned in the previous video about the PWM itself. So this one is the CCPX count. So if you use the PWM1, so the CCP1X, CCP1Y, CCPM3, CCPM2, CCP1M2, and CCP1M0. So for this, you can only have you have don't try to store 000 for the CCP1M3 to CCP1M0 because there's only one for the PWM mode is the 11 don't care. So you need to store the value 1 right here. Okay, here 1 and XX. This one is according to the PWM mode, is just only here. So you can ignore this configuration because that configuration is not for the PWM itself. So the other way is the least significant bits, the PWM least significant bits or LSB, PWM duty cycle, store in here. Okay, bit 4 and 5 and the CCP con. Okay, next is how to configure the PWM. There are 5 steps. First one, you have to configure the CCP1 for the PWM1 module. For the this is PWM1 operation. Set the PWM period, that's general, by writing to the PR2 register. Okay, so the PR2 register so the timer 2 register will be compared to the PR2 itself, because the PR2 holds the PWM period. The third step is set the PWM duty cycle. You have to write the PWM duty cycle to the CCPR1L for the PWM1, or the CCPR2L for the PWM2, and the CCP1 con or the CCP2 con. This the first three steps. And the first step, you have to make the CCP1 or CCP2 pin as output by clearing the 3C2 or 3C1. Okay, clearing. So you need to store the zero logic to here, because the zero logic is according to the output of the pin itself. So don't forget to make the CCP1 pin or the CCP2 pin as an output by clearing the according 3C. Okay, maybe 3C2, 3C1, or either 3C2 and 3C1. And then you can turn on the TMR2, but first you have to set the TMR2 prescale, and then you can turn on the timer 2, writing the T2 con. So the PWM1 and also the PWM2 they have only one timer to operate, which is the timer is TMR2 itself. So again, you cannot use the timer 2 if you use the PWM facility or PWM features in this kind of microcontroller. So if you use other microcontroller, maybe you have to learn using the datasheet, because maybe the operation or the configuration is very different from this kind of microcontroller. Okay, so this is the example that example of the step of the configuration of PWM. Okay, sorry, the first one is the main. So you need to make it first duty cycle is equal to 0, because this is the definition, the declaration of definition of the variable duty cycle as character or integer here, right here. And then you have to configure the port C as output. Okay, 0 0 for simplicity, for easy access, because we don't need other pin in the port C for other application. So you can store the 0 value of this to the 3C, so that each of the pin of the port C is always output. Okay. The second one, you have to make the PWM mode and the CCP1 con. Just I like mentioned before, you have to store this kind of value. Take a look at this, 1 1. Okay, 1. This is 1, and also this is 1 on 0, all 0. This is 0. This is 1 1 1 1. So 0 FF. This one 0 F. Sorry, not FF, 0 F. And then set the duty cycle time to 100 using PR2 for varying the duty cycle from 0 to 100. And then CCPR1L, by default the duty cycle is 50. Sorry. The TMR2 on bit 1. So activate the timer 2 to generate PWM. Okay, this is the infinite loop according to the main program. It's only to bright the LED, and then to high bright, and then to low bright, the low intensity or high intensity, and the LED connected to the RC2, because we use the PWM1. So for duty cycle equal to 0 until duty cycle less than 100, keep increasing. Okay, the CCP-R1L is duty cycle. Okay, delay 1 second. So this kind of delay is not accurate, but it's enough to our example. And then after the LED is bright for the 100 duty cycle, and then decreasing the duty cycle 100 to 0. This one using the duty cycle minus for the decreasing or reducing, and the other for increasing is using the duty cycle plus. So it's also the same that we need to send the duty cycle to the CCP-R1L, this one, and then we can delay about 1 second. So the output of this program, if you use the LED connected to the RC2, okay, RC2 here, RC2 for the PWM or the RC1 for the PWM2, you can see that the LED will be light up until the maximum or the duty cycle is 100, and then light down until 0, until the LED is off. That's very simple, and so on. Okay, and so on. The increasing and also the reducing of the light intensity is delayed by 1 second or 1000 milliseconds. Using the delay, that you know that the delay is not accurately, but it's enough to our example. So if you don't want to get accurately use the delay time, you can use the function of the delay itself. Just don't worry. But if you want to accurately delay, you cannot use this function of delay. You have to make the delay timer using the timer. Just in the previous video, we talk about the timer. You can see it if you want. So this is the oscilloscope display using the RC1, RC2, and also the RC2 25%, yes, 75%. The inverse, okay. We have 2 channels here to show you that in reality this one is increasing 25, 26, and so on until 100, and then reducing 100, 15, 25 until 0, and so on. Okay, so we need to know about the PWM functions in micro C because we use the micro C compiler. The first one is PWM1 init. This function just let you know that you can use the 2 here if you want to use the PWM channel 2. But in this slide, for example, we use the PWM channel 1. So you need to write, or you need to use the PWM1 init for the PWM channel 1. If you want to use the channel 2, you have to write PWM2 init. So this function has only one parameter, which is the frequency itself. To initialize the PWM module using the duty ratio of 0 for the first time of 0. The frequency parameter is the desired frequency in hertz. So you have to write here in hertz, okay, and must be in the number constant, not variable. So if you want to use the PWM1 init, for example, you can write PWM init 100, okay, not PWM1 init frequency, but you have to be this parameter is to be constant, numeric constant. Okay, and the second function is PWM set duty. This function is used to adjust the PWM duty cycle. So the parameter is also only once here. The duty ratio parameter takes value from 0 to 255. Namely, 0 means 0%, 127 means 50%, and 255 means 100% duty cycle if you want to use the full length of the numeric itself. So the PWM1 init function should be called or must be called before using this function. Okay, so this is the first two of the function of the PWM and microSIM. The other is to start and to stop. The PWM1 start is to start the PWM output, and the PWM1 stop is to stop the PWM output. So just be careful, because you can start the PWM after initialization, okay? And always that you can stop the PWM after initialization and after start. What you can stop that never start, okay? So you have to make it start first, and then you can stop next. Okay, yeah. So this PWM start must be called before calling this function. Otherwise, it will have no effect. Okay, because the PWM mode is not in running mode. Okay, this is four functions: PWM1 init, PWM set to T, PWM1 start, PWM1 stop. This is note that the first note that for microcontrollers with more than one CCP module, to use the CCP module, for the PWM generator, change the number 1 with selected module. For example, PWM2 init, PWM2 start, PWM2 stop, and so on. All PWM modules in the PIC microcontroller use timer 2, just I mentioned before, for the operation. So you cannot set a different frequency for other PWM modules, and you cannot use the timer 2 for other application, because the timer 2 is already used for the PWM generator. Just remember it. And the second things that are important, that you can only have one frequency for 2 channel of PWM. But don't worry, because each of the PWM channels can have a different duty cycle. Okay, so just don't worry. But that 2 PWM channels have only one frequency. Okay, that's the things that you have to remember, and to make it we have to make it clear from the beginning. Okay, so in the last time, in our discussion, we want to talk about the example of PWM application. What we have here in the PIC microcontroller connected with 4 switches. Okay, 4 switches. The first and the second switch is using PWM channel 1. The third and the fourth switch use the PWM channel 2. So the switch 1 is to increase the PWM duty ratio or duty cycle produced by CCP1. But the switch 2 is to reduce. Okay, switch 1 to reduce, to increase the CCP1 duty cycle, switch 2 to reduce the CCP1 duty cycle, and switch 3 to increase the CCP2 duty cycle, PWM duty cycle, and switch 4 to reduce the PWM duty cycle for CCP2. Okay, so the switch 1 and switch 3 to increase the PWM duty cycle, switch 2 and 4 to reduce the PWM duty cycle for its PWM channels. So this is the circuit. What we have here is a switch connected to the each of the switch connected to the RT0, RT1, RT2, and RT4 using the pull-up register. So if this switch is pushed, then you can see 0 from this, for example, RT0. So this is active loop. And for the example, we can connect it to the CRO. Okay, or maybe you can connect it to the LED itself. So in the main program, we have to set the current duty 1 and current duty 2. Each of this current duty is equal to 16. The initial value, in this Indonesian and bahasa language, nilai awal untuk current, the initial value for the current duty 1, initial value for the current duty 2. So 3D, because the switch is connected to the resistor, so port T as input, but C is an output, because we can connect it, the RC1 and RC2 to the LED or the CRO. So okay, we initialize the PWM1 and also the PWM2 for 5000. Okay, just let you know this is the frequency. PWM1 init, long frequency. Okay, so I think it's very confused if you know that the this kind according to the duty cycle, the frequency of the duty cycle, not the source of the frequency itself, because the source of the frequency itself for PWM and PWM2 have the same source for the frequency itself. Okay, this is 5000. Okay, we can start the PWM1 start, PWM2 start, and then we can set the duty cycle just here, like here, 16. So PWM1 set duty 16, PWM2 set duty 16. So while one, if we, okay, that's active low. So if you push the RT0 switch, if the switch RT0 is pushed, first you have to delay, it's about 40 milliseconds. The current duty is going up, and then you have to change the duty cycle right here. But if you push the second button according to the RT1, the current duty is reduced, decreasing, and then you have to change the duty cycle for the PWM set. So this is for the switch 1 and switch 2. And for the switch 3 and switch 4, just as you can see that in this, if the RT2 is pushed, then also the same as the RT0 is pushed, the current duty for the PWM1 is increased. This the current duty for the PWM2 is increased. And then you have to set the duty cycle itself using the PWM2 set duty. And also for the RT3, just like the RT1, you need to decrease the current duty for the PWM2, and then set the duty for the PWM2 set duty using the current duty too. And then delay 10 milliseconds for all the loop. So this is the infinite loop. Okay, so you can see the the explanation about this program in this channels. Okay, this one channels. Okay, just take a look at here.
In this tutorial we will output loads duty cycle from the CCP. This circuit 4 switches are provided.
Okay.
You can get the source code and its explanation from our website electrosome.com.
So this one connected to the LED, yellow LED, and also the second one connected to LED. This according to the PWM2, this according to the PWM1.
Now let's see the output of our PWM experiment. In this experiment you can see that the LED brightness is changing with PWM duty cycle.
Okay, that's the output of the our example. It's so simple and easy to understand about the PWM, also to use the PWM. Just remember, if you want to put some the robot, especially for the humanoid robots, you can use this facility or these features regardless of the microcontroller itself. You can use other microcontrollers as you wish. But remember that the PWM operation is different. the concept is also the same, but how to configure, how to operate this facility, the PWM facilities, is maybe different or slightly different from one microcontroller to the other family microcontroller. For example, if you want to use the STM32 microcontroller using this, their PWM is very different approach, but the concept itself it's also the same. So don't worry if you want to use the PWM operation, regardless of the microcontroller, you can use always the same concept of the PWM itself. So if you want to for example, I don't want to use this kind of microcontroller PIC16F877. I want use the 8 Mica. The 8 Mica is also have some of the 8 Mica have PWM facility features, but the operation is different, but the concept is also the same. So you can learn more about the how to configure, how to operate the PWM function or PWM features from other microcontroller, and their tutorial, and their maybe you can search in the YouTube for the Arduino. Maybe the Arduino is very simple. Okay, it's very simple. If you want to use the PWM in the Arduino, and you have watched this video, it's okay. More simple, but the concept is always the same. Okay, that's it for the PWM lectures from now, and we will discuss about I2C and also SPI and the next video, because this is the video number 11. Okay, 11 from the 14 videos.
In this
Okay, thank you very much for your attention. Please, if you have a comment, if you have any question, you can write in the bottom of this video in the comment section. Thank you very much. See you for the next video.